channel. So as we have started the series of chapter number 6 of thermodynamics. So now let's begin. So first of all, I am writing the topics which we are going to discuss today in the part 2. So first of all, we will discuss about types of processes. Types of process. Second, there will be some difference between, there will be actually two difference between processes. One is isothermal and adiabatic, one is isochoric and isobaric. The difference it will be, and the second topic will be first law of thermodynamics. So now let's begin with the first unit, which is the type of process. So type of process. Let's go with the first. First process is known as isothermal process. So let me write it, isothermal. Second is known as isobaric. And the third is isochoric, and the fourth is very important and it's new also, which is called adiabatic process. That is an important process which you may have to remember. So the third is isochoric. And the last two, but very important, adiabatic. So now let's begin with the first process, which is isothermal. Actually, thermal means, you may come to know that it actually means temperature. Thermal we can say. It means almost like temperature only. So we are here in this case we are dealing with a process where suppose we are doing a process which is done at constant temperature, where delta T equals to 0, means a process where delta T equals to 0. Delta T denotes change in temperature. There will be no change. Suppose, now let me take an example. Suppose we have done reaction. In reaction we get products and reactant also. So initially we have done the process at 25 degrees Celsius, and after this we will not change the temperature here. The temperature will be initially and finally both, it will be 25 degrees Celsius. Yeah, note that point. Whenever in question we are given temperature in Celsius, we have to convert it into Kelvin. In Kelvin we will not be denoting with degree, then the teacher may give you wrong. You should always write at K which denotes Kelvin. Let's see, where pronunciation we denote 25 degrees Celsius. So it is degree Celsius, but we cannot say 25 degree Kelvin. That is inconvenient. So let's write, for converting into Kelvin, Celsius to Kelvin conversion. So if you are given, let's take an example of 25 degrees Celsius and we have to convert it into Kelvin. So how will you do it? So nothing, we will just add 25 with 273.15 equals to temperature in Kelvin. Yeah, 0.15, it's your wish. If you want, you can take it 0.15 also, or you can only take it as 0.0 also. We can also take it as 23 also. So the temperature here would be 273.25.892, which is 298 Kelvin. So we can say 1 Kelvin equals to 273.15 degrees Celsius. Sorry, it's wrong, sorry, my mistake. 1 Celsius degree equals to 273.15 Kelvin. This is right, yeah. Celsius degree equals 1 Celsius degree equals to 273.15 Kelvin. Note that I am not writing as degree Kelvin. So you might now be clear with the isothermal. So now let's go for the isobaric. So remember the trick. Here it is we can write at bar. Everyone knows that pressure equals to force by area, which is Pascal or Newton per meter square unit. I am telling about bar. We always write pressure in terms of bar, like 1 bar, 2 bar, 3 bar. Conversion I will teach later. So isobar, see we have written it isobaric, sorry. So here the pressure would be constant. Any process that is occurring at pressure constant is known as isobaric. At pressure temperature, so isothermal. Here delta P means change in pressure equals to 0. Some terms like delta T, delta P, delta V, then here we will write delta Q equals to 0. Yeah, that will be useful in some laws, in like first law of thermodynamics only. So now let's go for the isochoric. Isochoric is nothing but here the volume is constant. Volume is constant. So means after reaction or before the reaction, the volume will be same. Means there will be no change. So you can write delta V equals to 0. Adiabatic. So this is very important. I am writing a star here. Adiabatic is a process in which no heat exchange is there. I have told in the last video only that we denote is that Q. Heat, we denote it as Q in thermodynamics. So adiabatic is a process, no exchange of heat. No exchange of heat means delta Q equals to 0. So these were the 4 types of processes. So now I will go for the difference between, as I told in the first. So now let's go for isothermal and adiabatic. Isothermal and adiabatic. Difference we are writing. So now let's go for the first point. Here as I told that thermal means temperature, so here temperature will be constant. Temperature is constant. That means delta T equals to 0. In lastly I talk about adiabatic. Here no exchange of heat occurs. No heat exchange. No heat exchange. So we will here write delta Q equals to 0. You can write small also and big also. There is no problem in that. So now let's talk about the types of system in this both. Here the system is thermally conducting. The system is thermally conducting system. And here is thermally insulated system. Thermally insulated. here now the third point will be according to the first law of thermodynamics, but you can write it now. I will teach in the next one only. By first law of thermodynamics, delta U equals to work done plus heat. You see here, temperature is only constant, so delta U will be, see, temperature is constant, so there would be no heat supply. If heat supply is there, the temperature would be rise. Of course, if you are taking a plate or if, as you may see that boiling of water, when you start the gas, it starts slowly and slowly, and then the boiling of water starts. So here same occurs. As no heat is there, so temperature would be, there would be no change. If no change in temperature, there will be no heat generation. So Q will be equals to 0 for here. So work done plus 0, that is delta U equals to 0. Here delta U is not equal to 0. And the fourth point of this is related to specific heat. Specific heat capacity is nothing, but it is the heat required to raise the temperature of one unit. Means the amount of heat required to raise the temperature of mass by 1 degree, means it can be either Celsius or Kelvin. That is called specific heat. Till now you remember this, then we will go in further. So for this we denote it as Q equals to infinity. And here fourth point, for this Q is equal to 0. Q is equal to 0. So I hope that you are clear till now. So now let's go for the next difference between, which is isobaric and isobaric. That's only 1 point difference. So I am not writing it, but I will be just explaining to you once. That see, isobaric I told that volume remains constant, and isobaric I told that pressure will be constant. So now let's go for the first law of thermodynamics. You note it down. I am just taking my notes. So in today's video, I am not going in this in detail, but I am sure that in the next video I will be going in very deep. There are lot of changes in its formula. Let's see what does first law does say. This law was proposed by Helmholtz and Robert Mayer. This is not important, but I am just telling it. It was proposed by this. क्या फर्क पड़ रहा है, इसको याद ना रखें तो भी कोई बात नहीं. Now let's go for the statement. It states that energy of an isolated system is constant. That is, energy can neither be created nor destroyed. That is why we also call it as law of conservation of energy, where there is no change in energy. Energy will be constant. Law of conservation of energy. So now let's move further. See, suppose we are taking a system. Suppose we take a system. In today's video, I am just deriving the formula. In next video, we will go for the different types of formula or the representation of first law of thermodynamics. Then we will go for what is delta U and what is enthalpy, which is denoted by delta H. It's very easy concept, but it is a very important topic. Suppose a system consumes, uses, or we can say a system is there, it may always consume heat. So let the amount of heat be Q and the work done for this be W. And the process, the internal energy of a system changes from U1 to U2. There is internal energy change, so we can write here delta U. What does first law of thermodynamics say? It's nothing, it is just delta U, that is change in internal energy, equals to heat consumed plus work done. So this was the first law of thermodynamics. There are basically lots of representation done on work, that is work done by reversible process, irreversible process, that I haven't taught till now. So and on basis of Q also there are so much formulas. So that's end of today's video. Please subscribe my channel, hit the bell icon, like the video, and do comment below if you like, and comment for further video. Thank you.